Okay, so hello everyone. In this video, we will cover classless IP addressing. So in this video, we will discuss classless IP addressing and then the very important topic subnetting in classless IP addressing and then VLSM, variable length subnet masking in classless IP addressing. So the very first topic is what is classless addressing. So the concept of classless addressing came in 1993 after the concept of classful addressing. In classful addressing, we divided the IP addresses into 5 classes, but this creates problem with flexibility and other disadvantages also. Okay, so the first important point is that there is no classes, there is no concept of classes. First point, there are no classes here. Forget about A, B, C, D, E. There is no concept of classes in classless addressing. Now, what is the system in classless addressing if there is no classes involved in this system? Block system. Here is the concept is of blocks. A block means if a user says that they want X amount of IP addresses, then I provide exactly X amount of IP addresses. Whatever the user demand, I provide that size of block. But in classful addressing, there's no flexibility for the user. If a user says they want 1000 IP addresses, there's no provision for exactly 1000 addresses. If I give class A address, there are 1 crore addresses in that network. The user demanded only 1000, but I can't fulfill that exact demand if I am following classful addressing. In classless addressing, wastage of IP addresses is very minimal because whatever the user demands, I provide a block of that exact size. Okay, this is handled by IANA, Internet Assigned Number Authority. The block size that user demands will be provided to them. Now, what does block mean here? We have block ID and host ID. Earlier we had network ID and host ID in classful addressing, but here we have block ID and host ID. In IPv4, IP address is 32 bits. We have discussed it before. The MSB bits, the most significant bits, represent the block ID. Okay, the network we are talking about. The other bits represent how many hosts are there in the block. Now, what is the notation system? The notation system in classless addressing is x.y.z.w, the same 4 octants, but the new thing here is oblique n. What does this oblique n notation mean? Here n represent the mask, the number of bits representing the block or network. This is n. What's the purpose of n? If an IP address is given to me, how will I know how many hosts are there or what the network ID is? The n helps me determine this because n works as mask. Mask means continuation ones. Okay, the number of ones is represented by oblique n, which we can also say that this is the number of bits used to represent the network ID or block ID part. Now we will take an example. We will understand it better in this example. The example we are taking is 200.10.20.40/28. This is a normal IP address, but what's new here? /28. Okay, the concept of 28 means there are 28 continuous one, meaning the network ID part is represented by 28 bits. Okay, the whole IP address is of 32 bits. So how much is the host ID part? If this is a 30-bit IP address and 28 bits are for network, then remaining 32 minus 28, 4 bits for host. The first question you might be asked, which network does this IP address belong to and how many hosts are in that network? Taking /28 first, 28 means 28 continuous ones, which is the network ID part. So network ID part has 28 bits and the host ID part has 4 bits. Number of hosts is 2 to the power 4, 2 raised to power 4 equal to 16. So number of hosts is 16. Now finding the network ID. To find the network ID of this IP address, I need to determine which network this belongs to. Okay, in classful addressing, each class had its own mask. Here I don't know the mask, but I know that the n represents the mask, the number of ones. You can write 28 ones as 1111111 dot 1118 ones, then dot 8 ones, then dot 8 ones. Okay, and then 1110000. The last 4 bit is 4 zeros. Okay, why? Because there are 28 ones only. Okay, total 8 plus 16 plus 24 plus 4 equal to 28. Now converting this to decimal, 255.255.255.240, this becomes the mask of this network. Simple method of finding network ID. Here is the simple method. In this IP address, keep the first 28 bits from MSB exactly as they are. Okay, don't touch the 28 bits. 28 bits mean 200 represent 8 bits, 10 represents 8 bits, 20 represents 8 bits. That's 24 bits. We need 4 more bits from 40. Okay, representing 40 in binary 00101000. Now take the first 28 bit, the first 24 bits 200.10.20 plus the first 4 bits of 40 0010. Make the remaining host bits, last 4 bits all zeros. Okay, 0000. So 0010 and 4 zeros in binary is equal to 32 in decimal. Okay, now therefore the network ID is 200.10.20.32/28. what is the alternative method? AND operation. Okay, you can also use the AND method. Take the mask 255.255.255.240 and AND it with the IP address 200.10.20.40. Now 250 I AND with any value gives the same value, as I have discussed this in previous lecture also. 240 in binary 11110000, 40 in binary 00101000, and result is 001000 equal to 32. Same result. This is the alternative approach. 200.10.20.32 oblique 28. This is the network ID. Okay, now what are the rules for classless addressing? Addresses should be contiguous. All addresses in a block should be contiguous, like 32, 33, 34, 35, 36. No gaps should be exist. Now second rule is number of addresses must be power of 2. In our example 16 host 2 to the power 4, which is valid. First address must be evenly divisible by block size. Okay, the network ID should be divisible by block size. In our example 32 should be divisible by 16 block size. Now to check divisibility, since block size is 2 to the power 4, the last 4 LSB bits should be 0.32 in binary. Okay, 001000, last 4 bits are 4 zeros. Okay, so it's divisible. If the IP address was 33, 001000 and 1, last 4 bits are 0001, so it wouldn't be divisible. Okay, this is the complete concept of CIDR, classless inter-domain routing. Okay, now we will discuss the very important topic, subnetting in CIDR, classless inter-domain routing. As we discussed subnetting under classful addressing, now we will discuss subnetting in classless addressing, where there are no classes and we use slash notation to denote CIDR address. In CIDR we don't have classes, instead we use slash notation. Okay, for example, let's take the network 195.10.20.128/26. Okay, the slash 26 denote the number of network bits, meaning 26 continuous ones represent the network ID. Okay, since IP addresses have 32 bits in total and 26 bits represent the network, the remaining 6 bits 32 to 26 represent the host ID. Now finding the network ID, if we have 26 network bits, first 3 octants are 195.10.20. Okay, 24 bits. Last octant is 128, needs to be examined. When we convert 128 to binary, it becomes 1 followed by 7 zeros. Okay, since we have 26 network bits and already have 24 from the first 3 octant, we need 2 more bits from the last octant. So the first 2 bits 1 and 0 of the last octant are network bits. Okay, and the remaining 6 bits are host bit. Sometimes you might be given a host ID instead of network ID. Okay, for example, if given 195.10.20.129/26, you would convert 129 to binary. This would be 10000 and 1. Then make all the host bits 0. Okay, find the network ID, which will be 10000 128 in decimal. So the network ID is 195.10.20.128/26. This was our network ID. So this was the important note here. Now subnetting in classless addressing, with 6 host bit we can have 2 to the power 6, 64 hosts in total. Okay, but only 62 usable after subtracting the network ID and the broadcast address we have discussed in our previous lectures. Okay, to create subnets we fix the most significant bit from the host ID. Okay, let's fix the third bit, first host bit, as 0 for subnet 1 and 1 for subnet 2. Now for subnet 1, what is the fixed pattern? 1000000. First 3 bits fixed at 100. Remaining 5 bits vary from 000 to 11111, as we discussed it. Okay, now what is the range for subnet 1? 195.10.20.128 to 195.10.20.159. 32 addresses are there. Now what is the network ID? Network ID is 195.10.20.128/27. Why 27? Because we have fixed 27 bits now. So for subnet 1 this will be /27. Okay, now what is the broadcast address? Broadcast address, the last address is broadcast address 195.10.20.159. Okay, this will be broadcast address. Now usable host, how many usable hosts are there in subnet 1? 30 usable hosts. Okay, the first and the last is broadcast address and the network ID. Okay, now for subnet 2, now we have fixed 3 bits here, 101. We have fixed 3 bits here, 101. Okay, in last octant. Remaining 5 bits vary from 000 to 111. The range will become 195.10.20.162, 195.10.20.191. There will be 32 bit addresses also. Okay, now what is the network ID for subnet 2? 195.10.20.160. /27. This will be the network ID. Okay, the first address is network ID. Okay, broadcast ID for subnet 2 195.10.20.191. This will be broadcast address. Okay, now how many usable hosts in subnet 2? There will be 30 usable hosts in subnet 2. First address and last address not included. Subnet mask notation. Originally we had /26. Okay, there was 26 bits fixed. Okay, but after subnetting we have /27 because we fixed one additional bit from subnetting. The number of fixed bits determine the slash notation. Okay, from 64 total hosts we now have 60 usable hosts, 30 plus 30, because each subnet has its own network ID and broadcast address. Okay, this is the fundamental concept of subnetting in CIDR. We fix additional bits to create smaller subnet while maintaining the network structure. Now the very important topic, VLSM in CIDR. VLSM, variable length subnet making in CIDR. Now we will discuss variable length subnet masking in CIDR, how to create subnets of different sizes in classless environment. Okay, now what is the scenario setup? An ISP, internet service provider, has the address 245.248.128.0/20. This is our address. /20 means 20 network bits. Host bits 32 minus 20 equals to 12 bits. Okay, total possible host 2 to the power 12 equals to 4096. And what are the ISP's requirement? Give half of the address to the one organization, then give quarter of the addresses to another organization, keep the remaining quarter for future use. Okay, this is ISP's requirement. So how we implement it, how we do this subnetting? So the very first step is understanding the network structure. 245.248.128.0/20. So opening the third octant, 128, binary 1 followed by 7 zeros. Okay, network bits first 4 bits 1000, host bits last 4 bits. Okay, 0000, plus entire octant, entire fourth octant 8 bits, 12 host bits total. Okay, so host bits are 12 host bits. Now what is step 2? Step 2 is first division, half division. To create two equal halves, reserve 1 bit, the MSB of host portion, as we discussed in previous example. Okay, now what is subnet 1? S1, first half. The fixed bit is 0. We have fixed the bit 0. Okay, the range is from 245.248.128.0 to 245.248.135.255. Now addresses, how many addresses are in subnet 1? 2048, half of total. Okay, I have met the first requirement. Okay, now subnet mask is what? /21, because we have fixed 21 bits. Now step 3 is second division, quarter each. Okay, divide the second half into 2 quarters by fixing another bit. Okay, so subnet 2, how many fixed bits in subnet 2? First bit 1, second bit is 0. Okay, now the range will become from 245.248.136.0 to 245.248.139.255. This will become our range. How we calculate it? We have discussed it. Okay, now how many addresses in subnet 2? 1024, quarter of total. And subnet mask /22. Why? Because we have fixed 2 bits now. Okay, 20 plus 2 is equal to 22. Now subnet 3, the second quarter of second half. Okay, so subnet 3 fixed, we have fixed 11 bits. First bit is 1, second bit is 1. Now range will become 245.248.140.0 to 245.248.143.255. Okay, this will become our range. And addresses, how many addresses are in subnet 3? 1024, quarter of total. Okay, subnet mask is /22. Why? Because we have fixed 2 bits here. Now 20 plus 2 is 22 bits. Okay, now key points here is never disturb the network bits. Okay, only work with host bit. Okay, now bit fixing strategy, fix 0 or 1 based on your division needs. Subnet mask calculation, original network bits plus newly fixed bits. This will be our subnet mask calculation. Now continuity is automatic. Okay, when done correctly, ranges will become continuous. This is the whole approach. If you haven't understand this concept, then you can watch our previous lecture, classful VLSM in classful addressing. So your whole concept will be clear. Okay, so that's it for this video. We will meet in next video. This concept was very important, and until then, bye bye.